All right. A two-factor ANOVA, also known as a two-way ANOVA. All right. It basically means that there are two factors, right? Here we have factor A of gender with two levels of male and female, and we have factor B of treatments with three levels of treatment 1, treatment 2, and treatment 3. All right. Inside, you get the total scores for each group. And if you look to the right, this will be the T of the row, right? So you have columns, which go vertically, which are the treatments, and you have rows which go horizontally, which is the gender factor. Okay, so the following results are from an independent measures two-factor study with n equals 3 participants in each treatment condition. Use a two-factor ANOVA with an alpha level of 0.05 to evaluate the main effects and the interaction. Calculate the effect sizes for the main effects and interaction. All right, so we're given big N, G. Again, this is all from chapter 13. You know what they are, sum of x squared. Okay, the new things that we have are column and rows, which we'll see. So again, SS between treatments. Same rule applies. You could do SS total minus SS within. We'll give you SS between treatments, but we'll solve it as well. So it's T squared, the sum of T squared divided by little n minus G squared over big N. So I just took all the T values from each box, squared them, and divided by little n. Now again, you could square them, add them, and then divide by 3 from the total. You will get the same value. But here I just followed exactly how the formula says to do it. 9 squared divided by 3 is 27. 18 squared divided by 3 is 108. 27 squared divided by 3 is 243. 9 squared divided by 3 is 27. 36 squared divided by 3 is 432. And 45 squared divided by 3 is 675. Minus G squared over big N, which is 144 squared divided by 18. When you take the sum of these numbers and subtract it from 1152, you will get 360. SS within, same thing. We're given an SS in each of these cells, right? Also, we can label these as cells. So you just add up all the sum of squares and you'll get 96. And then for total, you just do the sum of x squared minus g squared over big N, 456. And then you could check your work. 360 plus 96, which is between plus within. Remember, between treatments plus within treatments equals SS total. So that's 456. And also 456 minus 96 will give you 360. And 456 minus 360 will give you 96, all right? So as long as you have the total and one of these two, you can compute the other based off what's left. All right, and these are the two easiest calculations, so you technically could skip this step, but doing this step will just give you better confirmation that you did the work right, because as you all know, if you make a mistake early, it's just going to cascade through the whole entire computation for the F test, and you will get it incorrect if you made an error. So you have SSA, which is the sum of T squared row over N row. Okay, so rows are here. So it's the total of the rows, right? And here they're given, right? You'll see 54 and 90, right? And then when you go here, you'll see 54 squared divided by N row, and that's 9. Why? Because there are 3 participants in each cell, and in this row, there's 9. 1, 2, 3. 3, 6, 9. Okay. So now you just do that for 54 squared divided by 9 plus 90 squared divided by 9. And you get 324 plus 900 minus, again, G squared divided by N. We get this value a lot, so we know it's 1152. That's something also to look at, right, to save time. right? Once you do it twice and you get the same answer, right, you could be confident you got it right, and then you could just use that number and plug it in wherever else you see it in any other formulas. As you see, it's there too. So you get 72. And SSB is the same concept, only you're going to use T columns and N columns. And as you can see, N column here is 6. Well, how did I get 6? Well, here's a column, right? That's one column, and there's 3 participants per cell. So if there's 3 participants per cell, and we know that because there's 3 scores in each cell, and also the question told us that there are n equal 3 in each treatment condition, all right, or in each cell. So here they gave us the totals for the rows. They didn't give us the totals for the cells. So all you have to do is do 9 plus 9. You get T1, right? T of treatment 1. 18 plus 36, T of treatment 2. 27 plus 45, the T of treatment 3. And then it's the same way we just did SSA. You're just using those values. So you just plug them in. Plug them in just like this, and you'll get 252. And then to get SS interaction, that's simply SS between treatments minus SSA minus SSB. All right, 360 minus 72 minus 252 equals 36. If you got a 0 here, it means no interaction. If you got a 0 here on SSB, it means that SSB has absolutely no effect. Not even a non-significant effect. It has no effect on the study, and the same goes for SSA if you get a 0 anywhere, which will happen from time to time. So once you have all this information, you should also realize that SSA, SSB, and SSIB, if you add them up, 252 plus 72 plus 36, what do you get? You get SS between treatments, okay? So SSA, SSB, and SS interaction, which is A by B, is just SS between treatments broken down into 3 separate parts. All right, and once you have all that information, then you just get 6 degrees of freedom, right? The first one is DF between, which is number of cells minus 1. There's 6 cells, minus 1 is 5. DF within, well, sum of DF in each cell. There are 6 cells, and there's 3 participants in each cell, so 3 minus 1 is 2. 2 plus 2 plus 2, plus 2 plus 2 plus 2 equals 12, or 2 times 6 equals 12. DFA is number of rows minus 1. Well, there are 2 rows, right? There's a male row and a female row. So 2 minus 1 is 1. And DFB is number of columns minus 1, right? There are 3 columns, right? For treatment 1, treatment 2, and treatment 3. So 3 minus 1 equals 2. And then you get DF A by B, which is the DF interaction, which is DF between minus DFA minus DFB, which is 5 minus 2 minus 1, which equals 2. And then you get DF total, which is DF between plus DF within, right? We just calculated between is 5 and within is 12. So DF total is 17. And also realize the same for sum of squares goes the same for degrees of freedom. DFA, DFB, and DFA by B should equal DF between. And is that true? DF interaction is 2, DFB is 2, and DFA is 1. 2 plus 2 is 5. All right, so doing all these little checks, we could be confident that we computed this correctly. Now we plot all this information in the ANOVA table. So for all these different SS's, you just plot them. We just solved them all. So SS between, SSA, SSB, SS interaction, SS within, SS total. Plug them in. Same goes for all the degrees of freedom above. Just plug them in. All right, and now we know. So as far as what we need for F obtained, all we need is source A, source B, source A by B, and source within. So what you do here is you just go 72 divided by 1 equals 72. Remember, SS divided by DF equals MS for equal source. So if it's an equal source, meaning it's SSA DFA will give you MSA. So SSA divided by DFA gives you 72. SSB divided by DFB gives you 126. SS interaction divided by DF interaction gives you 18. And SS within divided by DF within gives you 8. All right, so now we're on to F obtained. So to get the F obtained, the within mean square is always going to be the denominator of your F test. All right, so to get your F obtained for source A or factor A, you're going to do 72 divided by 8. You'll get 9. For B, you do 126 divided by 8. You get 15.75. You do 18 divided by 8, and you'll get 2.25. Now, as far as your F criticals go, same rules apply as far as what's the numerator and what's the denominator, right? The numerator on your F table is the horizontal plane, and the denominator is the vertical plane. So the within will always be the denominator, so that will always be the second degrees of freedom. And these degrees of freedom right here will all be different, right? Well, they could be the same, but you got to take them separately because, see, B and A by B are the same, but they could be different. So the degrees of freedom of source A is 1 in 12. The degrees of freedom of source B is 2 in 12. And the degrees of freedom of source interaction, or A by B, is 2 in 12. So now you just have to go to the F table, and you have to get the critical values for those 3 sets of degrees of freedom, right? B and interaction were the same, and if you go, you'll get 3.88 for both because they're the same. And then for source A, you'll get 4.75. Now, as far as calculating effect sizes, the formulas are right here. It's just SSA. For effect size A, it's SSA over SSA plus SS within. For factor B, it's SSB plus over SSB plus SS within. And for factor interaction factor, it's SSA by B over SSA by B plus SS within. And you just plug these values in. Simple enough. And you get the effect sizes. And you come over here. You'll see the effect sizes. And you also see that the effect sizes are positively correlated with the obtained F, right? So the higher the effect size, the higher the F obtained, right? The 15.75 has an effect size of 0.72, all right? An effect size of 0.27 corresponds to a 2.25, which is a non-significant result, right? So there's a non-significant interaction here because the F obtained is smaller than the F critical. But there's a significant effect of source A and source B, right? We got a 15.75 is bigger than 3.88, and 9 is bigger than 4.75. And which has the bigger effect? Well, the bigger effect looks like it's source B, right? You have a higher F obtained compared to the F critical, right? 15.75 minus 3.88 is going to be a larger number than 9 minus 4.75, all right? That's just extra information. Really, only thing I'll ask you is which factors had a significant influence in this study, and you just do the same thing we did in the last test. You just compare the F obtained to the F critical. All right, so I just thoroughly went over this one question top to bottom. So the same goes for the other questions. So just follow these same steps for the other questions, because if you could do it once and you understand the process, different numbers don't change the process. All right, good luck studying.